All right, I have a sign here. It says Santa loves to self-promote. He is hanging a new Santa sign in his shop that weighs 7.50 times 10 to the 2 newtons. The sign is attached to 2 cables, so that cable A is attached to one side as shown. How much tension is in cable B? First off, there's some issues with this problem, right? It's not well defined. Somewhere in my conversion of my files, I've lost this information, so if you don't have it, please add it. This rope here is rope A. This rope here is rope B. And the problem also originally gave the angle of 35 degrees. I did talk about this in class, but just in case you're just watching it for fun, I'm going to add those things for you. Okay, so first thing I'm going to do here is draw a free body diagram. I'm going to just draw it down here. I have FG going down. You know what? I'm gonna take that back. I'm gonna draw right on there, just easier. Okay, so I have force of gravity coming down from the reindeer parking only sign, FG, and this tells me that the weight is 7.50 times 10 to the 2 newtons. That's a lot of information by the seams, but weight is FG, and 7.50 times 10 to the 2 is just 750 newtons. Just move the decimal 2 places over to the right. So it gives me FG, so that's exciting. And then here I have something on angle. Oh, why are we? Hello, there we go. So I'm going to break these up into components. Let's call this hypotenuse here. F tension in A. We'll call this F tension in B. Oops, it's on F. There we go. So I'm going to call this FT A, but in the X direction. And when I break this up, I'm going to call this FT A in the Y direction. Excellent. All right. So the question asks, hey, what's the tension in B? Boom. So we're looking for what is this? Now, I'm just going to foreshadow the end of this aloud for you. I'm going to very loudly foreshadow that I know the answer to this problem is FTB will equal whatever FTAX equals. The problem is I don't know what FTAX is. I don't know what FTA is even. So I need to figure that out. Now, let's go ahead and just use our problem-solving strategy, and we know one big thing. This is a sign that's hanging up outside of a shop. Let's go ahead and make the assumption that it's at rest. It doesn't specifically say it's at rest, but we're supposed to assume this. So I'm going to go ahead to the sum of the forces in the y direction. I have going upwards, I have the FTA in the y direction minus FG. I'm going to go ahead and tell you that equals 0 because the sign's at rest. Sum of the forces in the y direction, we have FTB, which is what we're looking for, yay, minus FTA x, and this is equal to 0 as well, again, because the sign is at rest. So I'm looking for FTB. Like I said right away, it equals FTAX. I just did that by adding FTAX on both sides. But I don't know what FTAX is, so I have to figure it out. I'm going to try and just kind of have a little thought process aloud with you. Oh, I undid something. It's fine. And I can figure this one out, FTAY, because I know FG, so I can figure out FTAY. I know 35 is the angle, and if I know the opposite side of the triangle, I can then find out the adjacent side of the triangle using the tangent function. So let me go ahead and show you how this is done. So first off, I'm going to get FTA by itself by adding FG on both sides. FG is equal to mg, but we don't need to do that. In this situation, it gives us that FG is equal to 750 newtons. So we didn't have to do any math. Score. So now we know that with our triangle, the opposite side of this triangle is equal to 750 newtons, which I actually knew right away because I know that this sign has to be balanced out, and the only other arrow pointing in the y direction is FG, which is 750 down. So I knew FTAY was 750 before I wrote the equation. However, it's just good practice to write the equation every time. Now that I have that, I have the opposite side of the triangle. The adjacent side of the triangle is FTAX, which is what we're looking for. We don't know the hypotenuse, but we do know that the angle is 35 degrees. So I have OA, which means I can use the tangent function. So I'm looking for the adjacent side. So I just need to solve this equation for the adjacent side. To do this, I'm just going to flip-flop these two. The adjacent side is equal to the opposite over tangent theta. Opposite side now is 750 divided by tangent of 35 degrees. Now, please make sure you have parentheses on the bottom, just in case. Make sure everybody, oh, I just went back to where I was. So, hold on, what was it? 750? Okay. This is a new problem. I'm going to clear all. 750 divided by tangent of 35 degrees. And I get 1071.111005. Okay, and this is newtons, because I have newtons divided by tangent, which is newtons. So this is going to be my FTAX, which is equal to FTB. So this is actually going to be my final answer, of course, after I round it to 3 sig figs. So my final answer to this question is the force of tension in wire B has to equal out the tension in A in the x direction. I'm going to get 1070 newtons, and while FTAX is to the left, FTB, which is what we're looking for, is to the right. So please be careful. Make sure you solve what you're looking for. Okay, so this one says how much tension is in cable B. Well, a lot of people will stop and they'll be like, FTAX is to the left, and that's what they'll say. But please be careful.